Alright, now the next thing we're asked to do is show this set of 3 rotations that we may meet when you're fixing 3 node critical clusters. Of course, we met them earlier. Now, as we said, there are always 3 nodes involved in the rotation. The small, the medium, the large. I just reorganize so that the medium is in the middle. The challenge you may have is if one of those nodes has children on the inside. And you know what, when we get to a question that deals with that, I'll explain. So we're going to delay that discussion of nodes on the inside that may be affected by the rotation but are not a part of those 3 nodes. So we're going to get that out of the way. Next question. What's the time complexity of fixing a single 3 node critical cluster? One 3 node critical cluster like that, you want to fix it. Time complexity would be?
Long 3. Is theta 1?
It will be theta 1. And the good thing about the rotations is that once you fixed it, it's done. There's no propagation.
Sorry, the first question didn't say a single chord? No, the same thing? It says 4 node.
Yeah, means a single. In English, we're like that.
I just want to color in.
Alright, now we're not going to spend much time on the deleting. I want to make sure you understand inserting. Deleting actually follows some more rules. It starts out by using the same binary search tree deletion rules. The only time we get into the additional rules that are not covered by the binary search tree rules would be if you've structurally removed a node that would be a black node. Because if you did that, then you'd have upset the black height. Remember, one of the rules of red-black trees is that from root down to external nodes, the black height must be consistent. So if you structurally deleted a node that has a black node, then you're going to have to do some fixing. In short, the process involves looking around close to that black node, close to that node that was deleted, to find another node you can turn into a black node. But we won't really go into that right now. It's in the manual. Now, we're asked to do some inserts into an RB tree. So we're asked to insert the values . Twelve, 10, 6, 15, 25, 32, 30, 50, 52. Okay, so we're going to insert 12. Of course, we end up with 12 as the root. Then we're going to which would end up being a black node. Because the root must be black. Then I'm going to insert
10.
So 12 is there already. You know it comes in as red. Does it stay there as red?
No, yet.
Why wouldn't it?
Okay. Well, after you do the next one,
So that's
you're jumping
done.
ahead.
Then I'm going to insert 6. So you have 12. I we done there?
No. No.
Why?
Because you can have two reds.
No red, no can red child.
Yeah.
So this is a 3-node critical cluster. So we're going to fix that by rotating, right?
Yeah.
To give 10 at the roots, 6 and 12.
Yes, because it's 6 is longer than 10. Okay.
Then we're going to insert 15. Which gives us 10. And then what happens?
Okay. 2 words, so you have to recolor. Oh, sorry.
4-node critical cluster. Why not rotate?
This one.
Big.
There you go. Just wanted to make sure that you could answer. So 4-node critical cluster we recolor. Then we're going to insert 25. So instead follow binary search tree rules when we're tagging on the new node.
2 words. You can have 2 words, so we're gonna have to rotate it.
Okay, because we have a 3-node critical cluster. And so the rotation is only affecting this set of nodes here. So for that set of nodes, 15 is now the root of that set. Then we're going to insert 32. I take off this side here.
Yes, yes.
Are we done? I turn it on.
Okay. 3-node CC, 3-node critical cluster.
Great.
So that's how we would note it if we're presenting that in an exam.
You could, you don't have to write down the 3-node CC. As long as you go through step by step and you show your rotations, I normally indicate the critical cluster when I'm doing it on the board to make it clear. And for now, I'll be writing down the type of critical cluster. For now. It's not that you have to do that. So we've tagged on 32. What do we need to do? However, 4 node critical cluster. And this was useful because it pointed out the fact that the rotation would have been local to that set of nodes. So we're going to recolor. So we have over 10. So in this group of nodes, the root will become red and these two become black. Note that after doing that, the black height is still consistent. Right, so from here, 1, 2.